This is Dr. Clayton, and I had a request to go over the naming of alkanes. So let me write that out here, alkanes. We could say here the alkanes are going to be the parent compound here. In this case, you can see what the molecule I have drawn. And we are going to determine the size of this and also the position of the groups. That's the whole purpose of IUPAC naming. So here we have the ending of an alkane is the ane part of that. And so the alkane then will be named as an alkane with ane as a suffix. So in finding the parent chain, we want to find the longest continuous chain regardless of which path we go down. So we have several scenarios. Let me start discounting this one here. Okay, there's a 5-carbon chain. Okay, and we can start, let me just start from right here. Here we have a 5-carbon chain as well. It could be a possibility. Let's analyze it. One more possibility here. I started all the way over here from the left to the right. Let me go here now to the right, from the right to the left. Again, 5 carbons. So what do we do? Which numbering pattern do we use? We have this one here from right to left. We head down this little segue, and notice we have right here, there is an ethyl group and there's an ethyl group here. Those are uniform. Also notice, well, let me go to this one. We have a methyl group and a methyl group right here. And those are symmetrical, in other words. So we could start at either one of those. I could have put the one up here, and I just chose to put it down here to be easy. So let's look at these right here. We have 5-carbon chain, and we have an isopropyl group. Okay, and then over here we have the same as the first one. We have a methyl group. And down here we have the ethyl group. That looked very similar to the first one here, where we had the methyl group and the ethyl group. So the rule is, after we find the longest continuous chain, we want to find the longest continuous chain with the most number of groups. That's the basis of the rule. And here you see that would eliminate this one. This is wrong because we only have one group versus the 2 groups on both those other structures. So it's still a legitimate isopropyl group, but the reason that the IUPAC system does this is to prevent too large of a group from being named. Let's look at these other 2 then. If we have a numbering system here from 1 to 5, where the methyl group has a 2 and the ethyl group has a 3. And then on this one over here, we had it where the ethyl group had a number 3 and the methyl group was a number 4. So let's write that out. 3 and 4 versus the 2 and 3. Now the rule is we want the first group to have the lowest number possible. Okay, if it is equal going in any direction, then we'll go to the group after that, if there is a group after that. And a lot of times there is. And you keep going out and out to additional groups that may be on the chain. In this case, we don't have that. Here we have 2 and 3 versus 3 and 4. The next group has to have the lowest number. And you see these are basically, these are smaller over here. 2 and 3 versus 3 and 4. So we can all automatically say this numbering system over here is wrong, of the longest continuous chain, because it was too high of the numbering for the groups. Okay, let's go back over here then. This must be the right numbering system that we have here, because we have the longest continuous chain. We also have the lowest number to the groups, and we have the most number of groups. Left that one off out there too. So now, notice that I did name, forgot to mention this, but I did name a group as ending in YL over here. So those are the groups. The parents always end in the suffix of the parent chain. So in this case, we had our suffix is a alkane. That's what functional group we're looking at now. And then we have 5 carbons, and this is where you have a table from 1 on out. Typically for most organic chemistry classes, organic chemistry 1 classes, we will have memorization of those names out to about 12 carbons. So 1 to 12 carbons, you need to memorize meth, eth, prop, but, all the way on out there. Look at that table and memorize it. But here we have 5 carbons, and so that is a pentane. Write that in, pentane. And next, we're going to look at the first letter in these groups and alphabetize those in front of the parent. And so here, ethyl goes before methyl because E goes before M in the alphabet. So we want this to be one continuous word. So and we'll put hyphens in between here. This is in the 2 position right here. And then we're going to put in the 3 position the ethyl. I need to jam that in there. Ethyl. Okay, and there is the name. We have 3-ethyl 2-methyl pentane. There's no spaces meant to be in between there, if you can understand my handwriting. And these are in alphabetical order, not according to the numbering. Notice that we had a 3 before the 2 over here because we were putting these in alphabetical order. I'll stop there and we'll talk about some more complex examples later on.